Hi, I'm an old guy and I do maths. Today we're looking at normal distributions. What is a normal distribution? Well, it's a graph that looks a little bit like a bell. It's often referred to as a bell curve. And it's probably easier if I use real-world examples to demonstrate what a normal distribution is. So, let's think about height. And let's think about a large group of people to which you might belong, such as a class or a school or a university, something like that. If you lined every one of the members of that group up and you put the shortest on the left and the tallest on the right, or the other way around, it doesn't really matter. What you would notice is that there are a small number of very short people and an equally small number of very tall people, but that the vast majority of people are somewhere around what we might call an average height, if we're just talking generally. And what we have in that case is a normal distribution with the vast majority of people clustered around a particular value of height. I don't know what it might be. It could be 5'10", 175 centimeters, whatever. But you'll have the people over 2 meters tall out here, and you'll have short people here. Right, so how do we read such a thing? Well, we would go from short height to large height here, and the values up here could be numerical, so how many people there are in the group, but you can think of it as being least likely down here and more likely up here. So it is more likely, if you go into this group of people, that you will find people at approximately the heights around here. And it's not very likely that you will find very, very short people or very, very tall people. That's how this works. And it works in a whole pile of circumstances. We see it in things like income, IQ, all sorts of measurements. We find it not just in humans, but in nature. For instance, the height of trees, a particular species of tree, you'll find that that's usually normally distributed. And very often, not always, but very often, the larger your sample, the clearer the normal distribution becomes. Okay, so let's have a look at a couple of other normal distributions here. So I said that they were generally bell-shaped, and we looked at the example up the top of this page. Now here are two other examples, and what you can see is that in this case on the left, what we have is we have a very small range. And so the normal distribution is squeezed much more at the base here than, say, over here, where we have a larger range. And so what we will have is we will have a bunch of, shall we say, tighter clusters here. Now, the mean here should be roughly, because this is a symmetrical distribution, it should be roughly, but not very roughly, between these two, exactly between these two numbers. It should be halfway, because it's normally distributed. The same is true here. And all that we can say for the moment is that the range of this data is smaller than the range of this data, with a consequent effect upon how the bell curve looks. Okay, moving along. Here's another example, rather extreme, but it really drives home the point. Again, the curve is symmetrical, so I haven't said it already, but I will say it now. Half the data in our sample is this side of the mean, and half the data is here. So roughly, exactly 50% should be there, and 50% should be there. Same here, 50% here, and 50% here. Now, this is as far as I want to go with this video. The range will often determine the shape of the bell curve, the normal distribution curve, and half the data should be here and half the data should be here. And as a little teaser for what is to come, I just want to say that it is possible to break these areas up into smaller and more manageable parts. So we can come to an understanding of how much data is in here, or perhaps how much data is in here. And I'll name what these breaks are. They're called standard deviations, and they're the subject of another video. Just get your head around what a normal distribution looks like and some of its characteristics. Range, 50-50 distribution, the mean, less likely, more likely. Thanks very much for watching. See you next time.